Hello, Algebra 2 students. For Mr. Fry on this Monday, February 8th, we're looking at quadratic application word problems. In case you missed it, he had number 1 done. I'm going to explain it a little bit, and then I'm going to show you 2, 3, 4. I'm just not going to do the last one. I want you to be able to do something on your own. So let's take a look at this. Number 1, Jason jumped off of a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by this function. The height in time, negative 16 time t to the second, you see it there, where t is the time in seconds and h is the height in feet. And what Mr. Fry pointed out is just change these to look like this. I even changed it one more to look like this. And when you go to Desmos, I mean, you could use your, when you search Desmos, there's a graphing calculator online that's very, very helpful. It's a heck of a lot easier to use than your graphing calculator. So you could use your graphing calculator too and plug this in, and you can get this information on there. But I will show you on the computer the other two. This is the one that I did in class. So figured out how long will it take for Jason to reach his maximum height. I think I did put this one on there. 480. Yeah, I did. It's the red one. So this is Desmos. And so it's going to be the red one. So I have to go way out. I mean, way out. Okay. And so I'm going to zoom in here. And you could see, all I did was plug this problem in, okay, using y. And you use this down here, this keypad, to type it in. Y equals negative 16. You just plug all that in. So I get rid of that so that I can see what I'm doing here. Okay, how did we get these answers? How did we know, time-wise and all that, and the maximum height? And well, here you could see. Back it up just a hair. Went too far. Okay, right here, this point is the time in seconds. That's way down there on the x, that I'm at 0.5. This would be 1. This is 0.5. So it's half of a second that it's taken him to reach his maximum height. This is the maximum height right here. This is your y-axis, or the y coordinate. So the x coordinate is the seconds, 0.5 seconds, and the highest point is the y coordinate, the 484. What was Jason's initial height? You could figure out his initial height. That was when x equals 0. So when x equals 0, 0 there, put a 0 there, you got nothing. You just have 480 left. So, I mean, you could just see that it would be 480 by just looking at the problem. Or you could look right here and see that, okay, when x equals 0, y is 480. Okay, so that was that first one. All right, so once again, Desmos, use Desmos. It just makes life so much easier. Taking a look at number 2. If a toy rocket is launched vertically upward from ground level with a initial, so ground level, that's why you don't have, see, this was started at 480. So this is not going to have anything back here. So it's at ground level at 0, so there's nothing. It'll be 0. So with the initial velocity of 128 feet per second, then its height h after t seconds is given by this equation. Once again, just change it to this, plug it into Desmos, and you're going to be able to get all of this information. And I did that one for you. Take a look at that information. This would be your x coordinate. How long will it take the rocket to reach its maximum height? 4 seconds. How do I know that? Well, once again, let me back out of here. Okay, it's the green one. See, I just plugged in. It's the going to be the green one, the second one. So, let me just keep all moving. Okay, so right here. That's the very top. That's the maximum. So it took 4 seconds. That's going to be my X value way down here. And then the Y value you can see is just 256. That's the maximum height. So the maximum height is 256, and it was 4 seconds it took to get there. How long did it take for the rockets to reach the ground? So what we're going to do is we're going to see, well, I mean, if it was 0 to 4 to get all the way to the top, it's going to be 4 to 8, you know, because 4 is going to be halfway. There, you could just figure it out that way, or you could look at the graph. Let me back out and show you way down here. 0 in, keep zeroing in right here. The green line, you can see, goes till 8. So that's when it comes back to the ground. So that would be 8 seconds, because your X, and that's going to be an X-intercept. That's when, you know, Y would be 0. You would have X being 8. All right, so for number 3, you are trying to dunk the basketball. You need to jump 2.5 feet in the air to dunk the ball. The height that your feet are above the ground is given in the function right there. What is the maximum height your feet will be above the ground? Will you be able to dunk the ball? So you plug this in, and you can see I did that in purple. And let me back this up, okay, and show you the purple one right there. So the purple one, after you plug all those numbers in, you will see that you end up reaching a height of 2.25. The very highest you're going to go is 2.25. You're almost at 2.5. So 2.25 is your maximum height. So you have to jump 2.5 in order to dunk it. So no, you will not be able to dunk it. Sorry. For number 4, same thing. A ball is thrown in the air. The path of the ball is represented by this equation. Just change it to this, y's and x's when you plug it in. Graph the equation over the interval on the following graph. Okay, so you're going to have, this is going to be 0, this is going to be 8. And so when you graph this, I got this information from, you know, plugging this in. This is going to be the black one, and let me back it out so I can find the top of the black one. Okay, right here. So the very, very top you see is at 416. So the maximum height of the ball is 16. It took 4 seconds to get there. How long will the ball be above 7 meters? Well, and then it asks you to graph it. So it went from 1 till 8 seconds, and it went all the way up to 16. So, and my graph isn't the best. I mean, so how long is it going to be above 7 meters? So let me go back down here to 7. And if you find 7, it's right there. Okay. So 7 is at 1.7, and then it goes over to here, starts to come down, and 7.7. So the difference between 1 and 7. So 1, 2, 3, 4, 5, 6, 7. That's 6 seconds. So 6 seconds that it's above 7 meters. In other words, it's 1 second through 7 seconds. It's going to be above the 7 meters, and that is 6 seconds total. Okay, so there's number 4. Now this number 7, go ahead and try it on your own. Once again, just plug this information in to your Desmos, and you should be able to get all the answers that you need.